All right, so here we're going to try and have some practice of how to do these electron configurations. So just bear with me a little bit. So let's say that we have selenium. So I'll mark selenium right here. And I'm going to have to march my way through the periodic table to fill up all 34 electrons. So the first 2 electrons are going to be in the 1s2 orbital. Then I'm going to go to 2s2 right here. I'm going to go all the way through this to 2p6, back to 3s2, filling completely up the third p energy level, going to my 4s2 energy level, filling up my d orbitals, which remember is filled in n-1, so this will be my 3d orbitals, all 10 of them, and now I'm back into the 4th row. So the 4, I'm in the p block, and I'm 4 into the p block, so that will be 4p4. So my electron configuration is going to be 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p4. And if I added up all the superscripts, 2 plus 2 is 4, plus 6 is 10, plus 2 is 12, plus 6 is 18, plus 2 is 20, plus 10 is 30, plus 4 is 34, that should equal my atomic number of selenium of 34 electrons. Now, this is a huge number of things to start to write down, so we have the shorthand form. So the shorthand form dictates that I look in the row above, and I look at the argon, the noble gas that's there, that's argon, and I look at the electron configuration of that, and that's this right here. So I can substitute in for this entire thing, 1s2, 2s2, 2p6, 3s2, 3p6, argon, and simply write as my shorthand argon, because that's what this represents, 4s2, 3d10, 4p4. So this is my shorthand, or what we call noble gas core, argon, right here, and then the remaining 16 electrons that don't fit into the argon configuration. Now, a couple things to be mindful of. One of the nice things about the noble gas core is that it shows us what the highest energy level is really nicely. It's the 4th energy level. So even though I have 10 electrons in the d orbitals, better than 4th row, I only have 6 electrons that are in the highest energy level, the farthest away from the nucleus. So remember that even though the d orbital electrons have a higher potential energy, and as a result are filled in after the 4s orbitals, they're closer, they're on the 3rd floor, not on the 4th floor away. So the farthest electrons are going to be the 4th energy electrons, the s and the p. And remember that those are equally distant away from the nucleus. Another thing that the noble gas core shows us is how many electrons are between these electrons and the nucleus. And that will become important when we start talking about z-effective or shielding. So as another thing, let's try another element. So let's try something here. Make my life difficult. Sure. Iridium. So iridium, I have to go through the 1s2, 2s2, 2p6 over here, 3s2 over here, 3p6 over here, 4s2 over here, 3d10 over here, 4p6. Ooh, where did my 4p6? I'm starting to run out of space. I'll put it over here. 4p6, 5s2, 4d10. Where are my d10s? 4d10, 5p6, 6s2. And you think 5d10, but I've got I forgot my f orbitals. They're down here. My f orbitals fill in later. So that will be 4F14. I got my 4F14 here. Now I go back up to 5D, but I have 1, 2, 3, 4, 5, 6, 7 into my D block elements. So that will be 5D7, which is right here. 5D7. Now, you'll notice that if I want to do noble gas configuration, my life is much easier. So iridium is in the 6th energy level, so I look in the 5th energy level to xenon, right? Xenon is right there. So all of these electrons here have the same electron configuration as xenon. So instead of having these electrons right here, I can take these out and simply say my electron configuration is xenon, 6s2, 4f14, 5d7. So you can start to see the beauty of the noble gas core, the shorthand form, and why we do that. So again, just to recap, when you're looking for the electron configuration, you place your pen or something to where you're trying to go to. And if you're doing the longhand, you simply march your way through the periodic table, through all the blocks that you're going through until you reach that element that you're looking for. Noble gas core is even easier. You take the row right above, so it becomes xenon, and this would be 6s2, 4f14, 5d10, 6p12. Yay. Now, one thing that's important is to remember that xenon's electron configuration, noble gas core, is not xenon. I still have to take the noble gas of the one before it, and so that would be krypton, 5s2, 4d10, 5p6.